Hey everyone, and welcome back to another episode of Amp Up Solar Talk. Today we've got another exciting guest. We've got Tony Vernetti from Enphase Energy, and he'll be talking about their all new fourth generation energy systems, what's new about them, and he'll also be talking about how microinverters fit into the big picture of solar today. If you're watching live, be sure and drop your questions in the chat. We would love for you to join in on the conversation. Hey, Tony, welcome to the show. Thanks so much for joining us today.
Hi, Kelly. You're welcome. I'm happy to be here.
Yeah, well, we're so glad that you're here. And for those who may not be as familiar with Enphase, tell us a little bit about Enphase as a company and your mission when it comes to solar technology.
Well, Enphase is mainly known for being the first company to manufacture microinverters and really kind of succeed in that particular industry. Solar inverters have been around for decades before Enphase came around, but Enphase decided to take a different approach. The company was founded by a couple of guys named Raghu Balur and Martin Fornage back in 2006. And they came from the telecom industry and decided that it was just a much smarter idea to produce one small inverter for each solar panel instead of having one large inverter for the entire system. At that time, and still to this day, the reliability of string inverters or the single large inverters does not compare at all to the reliability of microinverters. So they tend to fail after 10 to 15 years. And they also have issues when it comes to performance, especially in shaded conditions or partially shady conditions. So that was the origin of the company. That said, it was always the goal of the founders to develop a robust energy management system for a home that included a way to not just produce, but also to store the energy and allow the homeowner to have control over that energy. So that really is always was, but is becoming really the forefront of Enphase's mission. Or what am I saying? It's coming to fruition basically now that everything's coming together. We've got a pretty amazing battery system, again, that enables homeowners to store that energy and then have the ability to choose how to use that energy, whether it's to save money, to reduce their carbon footprint, or to simply just be less reliant on the utility grid.
Great. So what you're saying is the company really started from developing the microinverters, breaking away from the string inverters. And I'd like to dive deeper into that in just a little bit. But tell me, before we go there, what is the philosophy that Enphase has when designing their system? So how do you balance reliability, innovation, and user friendliness?
It's a great question, Kelly. The core kind of driving principles behind developing products at Enphase kind of revolve around three things. Safety is really high up there. We want to make sure that our products are safe and that homeowners feel completely at ease and comfortable with our technology in their homes. Performance is another very important tenet. The system needs to perform reliably and produce the energy that the customer expects from it. Safety, performance, and reliability, which is in line with performance. The systems have to work day in and day out with little to no maintenance over long periods of time, and really be kind of a hands-off, easy experience for the system owner. Since most homeowners are not high tech, they don't want to know all the ins and outs of the technology. They just want it to work as expected and save them the money they expect.
Right. Well, those are big ones. So I appreciate you saying that. I didn't mean to put words in your mouth there, but yeah, safety, performance, and then user friendliness and
reliability. Yeah,
for
absolutely.
sure. Yeah. So let's go back a little bit and talk to me about microinverters versus the string inverter setups and what are those and why do those differences matter?
Well, today, the key advantage of microinverters is reliability. Again, string inverters, you typically have one inverter for a home. For a large home or a business, you might have more than one inverter in the system. And as I mentioned, they don't have the same life expectancy of the other main component, the solar panel. Solar panels typically have 25 to 30-year life expectancies and warranties. String inverters have only 10 to 15-year warranties and life expectancies. So Enphase sought to solve that problem by producing a microinverter that had the same life expectancy as a solar panel, if not longer, of 25 years. And that's important because string inverters, when they do fail, the entire system is out of commission. And this is 10 years into the ownership of the system, so it's quite possible that the system will be down and out of commission for a long period of time before the homeowner realizes it. They might not even know until they get a utility bill 1 or 2 months later that's a lot higher than expected. The other advantage has to do with performance of the system, especially in partially shaded conditions. Microinverters convert DC from the solar panel to alternating current for the home at the individual panel level. So if you've got 20 panels and you've got shade on a couple of panels, it doesn't affect the rest of the system. With some of the other technologies on the market today, there is no way to kind of mitigate that issue, or not nearly as an effective way as microinverters when it comes to a partially shaded array. So that relates to performance and reliability. Performance in that you're going to get more energy out of an Enphase system over time because you don't have the same issues of shade impacting the performance of the system. And then reliability by not having what we call a single point of failure in the power conversion technology in the system. So it just makes for a much more resilient system that produces more energy over the lifespan of the system.
Great. So, what would you say to the people that would argue that there's so much conversion losses, and so they're less efficient with so many conversions? What would you say to the people that would argue that string inverters are better for that reason?
Yeah. Well, I think the main thing to clear up, and this is a little challenging because it has to do with the technology of how these systems work, is that there are conversion losses in DC coupled systems as well. By that, I mean non-Enphase systems that are DC coupled, whereas Enphase is considered an AC coupled system. There are conversion losses between different voltages between the solar panels, the optimizers, if it's an optimized system, the inverter itself, and then the battery voltage. And there are inefficiencies in all those additional conversions that you don't see on the data sheets because they're not required to put them there. Enphase, you see efficiency ratings for the microinverters or efficiency ratings for the battery, but you don't see the voltage losses on anything. So sort of a long-winded way of saying that at the end of the day, when you compare efficiency losses and voltage conversion losses, they're about the same. There are almost negligible differences between the two systems.
Great answer. And so, would you say that that is the biggest misconception, or are there other misconceptions that people have about microinverter systems? And are there any of those that you can clear up for us today?
I think the one thing that comes to mind is cost. There's maybe a perception that a microinverter-based system is much more expensive than a string inverter-based system, and it's not worth the extra money. The way that I look at that is that it's a small additional upfront investment for a system that's going to be much more reliable and produce more energy over the lifespan of the system. So the customer is going to make up for that slightly higher cost initially with more kilowatt hours produced, a lower maintenance system that's going to give them less headaches. And they're also going to get the customer support that Enphase is kind of known for, which is 24/7 support. If you call Enphase, you'll be able to talk to a human being in less than 5 minutes. And to my knowledge, there's no other major solar company that can offer that level of support. So again, better experience, more energy, more savings over the lifespan, which more than make up for perhaps a slightly different, higher cost difference.
Okay. So, can you think of any kind of installations where microinverters versus string inverters would be, how do I want to ask this? Where one installation would be better than the other? Are there any times where you would want to install a string inverter over microinverters, or definitely microinverters over string inverters?
Well, I would say that microinverters are the better solution in any circumstance for residential applications. For commercial applications where you're getting into systems that are perhaps 100 kilowatts or larger, the economies of scale that you have with string inverters make a lot of sense compared to micros. Although we are seeing some companies invest in multi-megawatt systems with Enphase microinverters. So,
Okay.
those decisions are made by crunching the numbers and deciding whether economically it does make sense, and in many cases it does. But to get back to your question, for residential systems, I think Enphase is going to be superior across the board. In circumstances where you have a roof that has many different facets facing different directions, microinverters really do well in those situations because, again, each panel operates independently. So if you got a couple of panels facing a different orientation than some other panels, every panel and microinverter pairing is going to maximize its own energy production. With string inverters, if you have panels facing different orientations, that's going to affect their electrical characteristics and potentially negatively impact the energy production of the system. And then, as I mentioned before, if there's a little bit of shade on the roof, which is really almost unavoidable, you've got chimneys, you've got vents, you've got trees, you've got perhaps a 2-story house right next to yours that casts a shadow in the afternoon. There's almost always going to be some shade on the roof. And really, there's no other technology that handles the negative impacts of shade better than an Enphase system.
Great. Thank you for taking the time to talk us through that. Now, let's get into this new system. The 4th generation Enphase Energy System. How is it different from the 3rd generation system? Give us a high-level overview of what this is and any specific challenges or feedback that you were looking to address with this new system.
All right. Well, let me start by pointing out some of the positives of our previous generation, the 3rd generation. This is a system that we came out with a couple years ago that had a new battery at the time called the 5P. And it was a very powerful battery for its size in terms of how much energy storage capacity it had relative to how much power it could output. So it was a very capable system at starting big power hungry appliances like HVAC systems. But the feedback that we got from installers over the past couple of years is that it just takes up too much space. In homeowners' garages or the sides of their homes, there's often a limited amount of space. And at the same time, our energy consumption in general is going up with electric vehicles, with electrifying appliances. So people are using more energy. So they need larger battery storage systems. And those things kind of came to a head. And we took that feedback to heart. And we made a much more compact system with the 4th generation system. And we also greatly simplified the system as well to make it a lot easier to install. So that at a high level, those are the two main things. Basically more compact, so it's less wall space, and then a lot easier to install, which is going to decrease the amount of labor required to install a system and make the Enphase system a lot more, the 4th generation system, more affordable for the same amount of energy storage and same performance.
Oh, we always like more affordable for same performance. That's great.
Everybody loves that one.
So what components are included in this system?
So I think the best place to start with is the battery itself. The new battery is called the IQ Battery 10C, and the 10 stands for 10 kilowatt hours. The previous generation, like I said, is called the 5P, and it had 5 kilowatt hours of capacity. So this one is twice the capacity in a single box on the wall, and you could see it pictured right there. The footprint on the wall is actually smaller than a single 5P battery, and that's because it's a deeper battery. So it does come off the wall a little bit further, which may or may not be an issue, but most of the time the advantage of a very small footprint on the wall itself outweighs any issues that the customer might have with the depth of the battery, especially when it's installed in a big garage or on the side of a home. It really doesn't matter if the battery sticks out a little bit further. What matters is the smaller amount of wall space taken up. In terms of the performance of the battery, it's very, very similar to the 5P. It's very capable in terms of being able to start big appliances like air conditioners and well pumps, which historically have been very problematic or challenging, I should say, for battery systems.
Yeah, that's really nice.
And the next major advancement of the system is what's called the IQ meter collar. So any backup power system has to have a way to disconnect from the utility grid so that while the utility workers are working on the grid, you're not backfeeding power and potentially electrifying the grid, which could hurt somebody. So you have to be completely disconnected from the grid. And the IQ meter collar is the way that we do it with the 4th generation system. The previous generation used a different component that was rather large, took up a lot of space, and added quite a bit of additional cost to that system. So we eliminated that big heavy component as the way to disconnect from the grid and built this IQ meter collar, which is literally the same dimensions as the meter itself. And in most cases, it just sits directly behind the utility meter. And it is the MID, or microgrid interconnect device, which disconnects from the grid. Now, the big advantage of the meter collar is that it means that basically all of the electrical loads, all those circuits that are already in the main panel, are automatically going to be within that microgrid and get backup power when the system goes off grid. With the previous generation, any loads that you wanted to have, any loads that you wanted backed up, that you wanted to have backup power when you're disconnected from the grid, you actually had to move all those circuits into another panel called the backup loads panel or sub panel. That was very time consuming and labor intensive. So this is a way to basically avoid all that extra labor and have a more compact and simple way of disconnecting from the grid.
Yeah, I like that. That sounds really great. We do have some audience questions. I'm sorry, did I interrupt?
I was just going to mention, I mean, the system is comprised of 3 main components. I covered 2. Okay. I may as well give you a little bit of information on the third one, which is called the IQ Combiner 6C. So for those that are familiar with Enphase, we've had combiners for years. This is a pretty big leap forward in terms of our combiner technology. It combines not just the solar circuit, but also the battery circuits. It also does load control, has that functionality built in, so you can automatically shed large loads that you might want to for stability of the microgrid or to prevent those loads from draining the battery. You can also connect an Enphase IQ EV charger into it. And there are several other things that it does, but basically it's a very robust and feature-rich component that allows the customer to have a lot more control over their energy consumption and load control as well.
Yeah, and that's what we're all going for, is control and energy independence, right?
Exactly.
Yeah, we do have some audience questions that I want to make sure that we get to. From Florida Solar Design Group, they say, thanks for taking the time to discuss Enphase 4th generation. What is the timeline to be able to parallel 2 IQ Combiner 6C on a single battery bank to cover 400 amp utility services?
Wow, that's a great question. You're giving me the tough high-tech questions right away, Kelly. Throw me into the deep end here. Okay, so this is actually something that is going to be available at launch. It's not something that's going to be delayed. The thing to keep in mind, though, is that because of the amp rating of the meter collar being a 200 amp device, you can't install it underneath the 400 amp meter. Just electrically, it's not compatible. So you essentially have to install 2 separate systems on a 400 amp split bus service. And you would have, one system dedicated to one of the 200 amp sub panels and another Enphase system for the other 200 amp panel. So you would be able to achieve whole home backup for that homeowner that has a 400 amp service with 2 separate Enphase systems. The thing that will come at a later date is integration within the monitoring system of Enphase, where if the customer logs into the Enphase platform, they'll be able to see it like it's one system. To my knowledge, that's not going to be available at launch, but it will be available. I don't want to give a time frame, but it's on the roadmap.
Great. Solar Steve wants to know, what's the process to integrate Enphase batteries later if I don't start with it now?
So the best thing to do would be to install a solar-only system with the new IQ Combiner 6C. It can work with solar only, and it doesn't have to be used in a backup situation. That's going to provide the easiest path for kind of adding on backup capacity or capability in the future. So again, solar only with a Combiner 6C, and then when it comes time to add backup capacity, you basically install that meter collar and then add batteries and tie those into the IQ Combiner 6C. That should be a pretty quick and easy upgrade.
It's always nice to know that there's scalability to systems. So nice to know that you can do that. Jacob Lopez he says, we're probably all wondering the same thing. How does it work with storage? Can we back up the whole home? Is Enphase going to have bigger batteries to keep up with Franklin, Tesla, EG4, etc.?
Well, our building blocks are not the same exact size as our competitors. We went from a 5 kilowatt hour to a 10 kilowatt hour battery. And you can think of it as a Lego in a kit. You can add up to 8. You can have up to 8 of our batteries in a single system, which is 80 kilowatt hours of storage capacity. Now, that is good for, I'd say, 90%, if not 95% of homeowners. The average home in the US uses somewhere around 30 to 40 kilowatt hours on a normal day, not when they're disconnected from the utility grid. So, our maximum capacity is quite high. If the customer is asking about our individual battery capacity, it's just not the way that we look at things. You can have 1, you can have 2 or 3 or 4 or 8. It really just depends on what that individual customer needs. And the Enphase system is an AC coupled system. So if that customer needs not just more energy capacity, but also more power, every time you add a 10C battery into an Enphase system, you're going to increase the power output as well, up to a certain limit, of course. But systems with 4 or more 10C batteries can output enough power to actually run 2 5-ton air conditioners at the same time. So it is a very powerful system, as well as having the energy capacity that homeowner needs.
Yeah, 80 kilowatt hours is still a lot of backup storage for sure. Yeah. So Shane McMinn says, for existing third generation systems with solar and multiple 5P batteries, I see where Enphase is developing the system controller 3M to work with the 4th generation IQ meter collar. When will the system controller 3M and the IQ meter collar be commercially available?
So to my knowledge, they are commercially available today. I will have to, if you want to give me their info, I can get back to them, Kelly, but I believe they are available today. The meter collar is probably the thing that might be holding that solution up, because the meter collar has to be installed behind the utility meter. It needs to be approved by that utility for that purpose. Installers usually are not allowed to touch the utility meter. And I'm in California, and I know for sure that's the case here.
Mm-hmm.
So essentially, once the utilities have approved for the installation of the meter collar behind the meter, then the 3M and the meter, 3M controller and the meter collar can be installed in that way. That said, I do want to be clear that the meter collar can be installed in any utility on a separate meter pan. So I'll just say that again, because this is something that trips up installers pretty frequently. The IQ meter collar, while it's designed to work behind the utility meter, it can also be installed in a separate pan downstream of the utility meter, and it can still do its job as the disconnect for the system. You may have to relocate some loads into a backup loads panel in that kind of configuration, but you will still be able to move forward with the IQ meter collar, even if it's not approved by the utility behind their meter.
That's really important, because not every location and jurisdiction is going to approve it to be applied to the meter. So that's great to know. Great. Okay, so Mark Stebbins, sorry about that, Mark. How do the batteries do outside in high ambient temps? He lives in Phoenix, Arizona, I believe.
So off the top of my head, the temperature operating range of the IQ batteries is around 122 degrees, or maybe even higher than that. It depends on whether it's charging or discharging. When you get above those temperatures, an Enphase battery is still going to work. It's just going to derate, meaning it's not going to charge or discharge at the rate that's on that data sheet. So in very hot climates like Phoenix, for example, I think is what you mentioned, well, we would recommend putting the battery inside, or definitely on a part of the home that's outside, that's not going to be in direct, being hit by direct sunlight, where it's going to, of course, be the hottest. But they mentioned ambient temperatures, so even if it's in the shade, it's still going to get quite hot. So in those cases, I would recommend putting the battery inside on the like internal garage wall.
Right. Good. Solar Steve wants to know, does Enphase or Signature Solar offer training for customers?
Well, I can speak for Enphase. I'm actually on the training team at Enphase, and we offer free online training through Enphase University. And this is required for getting certified, actually. So we really like the quality of installations and the kind of competency of our installer network is very important. We want our customers, the end customers, to have great experiences, not just with Enphase, but also with installers. So you can come to Enphase and Enphase University online and get trained in installation and design. And soon I'll be personally updating the sales certification as well. So you can be very well versed in the installation of the system. And we also offer in-person training in most, I should say, a lot of the major cities across the country. It does depend on the market. And we also have vans that have all the equipment installed on these vans. Those are our mobile training centers. So even if we don't have a training center in a warehouse at your location, there's a good chance that a van will come by and offer it hands-on in-person training as well. So we offer all of our training is at no cost. You simply have to sign up either regionally for those in-person trainings or just log in and sign up online for Enphase University.
Nice. And I can speak a little bit for Signature Solar. On our website, if you go to our events tab, we do have some training that we offer. I don't believe there is Enphase training listed there now, but it can be requested and some training can be developed if enough people requested it. But yes, we do offer training for all kinds of things, and most of the time it is free. If you had questions, you could also walk into our retail store and somebody could probably walk you through some of the process. The Enphase components are a little bit more in depth, and you would still have to go through the Enphase training and get certified that they offer in order to be able to install this. So Solar Steve also wants to know, can the Enphase batteries be charged by a generator?
So not at launch of the battery, but that is planned for early 2026. This is a feature that we had with the previous generation that was very popular, especially for those people that don't have utility service, that want truly off-grid systems, or people that have very frequent long-term power outages. They love being able to integrate a generator. So with the 4th gen system, again, we don't have that available at launch, but in early 2026, we are going to come out with an additional piece of hardware that's going to make it a lot easier to integrate a generator. And to be clear, the way that Enphase does this is actually superior to really anybody else out there. The integrator ties directly into the combiner in this with the 4th gen system, and it allows you to basically charge the batteries. That generator can be operating and providing AC power to the home at the same time as solar and battery, so everything can work together. Most other systems, it's an either or scenario. It's either the generator powers the home or solar and batteries can power the home, but they don't work together. With Enphase, they do, or like I said, with the 4th gen system, they will early next year.
Nice. Now, Tony, I do want to be respectful of your time. We are over time. We have a couple of more audience questions. Are you good with going through with those?
Sure, absolutely.
Great. So Florida Solar Design Group says, I have a follow-up on the question about using IQ Combiner 6C with solar only. Does this support sunlight only backup as a gateway to storage for customers when used with the IQ8 microinverters?
So that's a great question, because with the previous generation, we did have a feature or a configuration, I guess you would say, called sunlight backup, where you could provide backup power during the daytime as long as there was enough solar power to provide enough power for the home's loads. With the 4th generation system, we actually don't support that configuration, just to be really clear. We're not going to support sunlight backup configurations. Couple reasons. One is that it wasn't really a use case that there was much demand for. And the second thing is really just has to do with the electrically how the system works. For sunlight backup, you need to have a neutral from the system to power 120 volt loads. With the old system, we had that neutral provided by that separate component called the system controller. In the 4th gen system, we don't have a controller anymore. It's gone. The neutral is provided by the battery. So that means to power 120 volt loads, you need the battery, period.
Gotcha.
So that's fundamentally electrically why we can't do sunlight backup without that neutral from the battery.
Okay, thank you. And My Solar Addiction with host David Newman, he says, you mentioned that DC coupled arrays would have energy loss due to voltage differences. Do you have any data to back that up that I can reference? Why doesn't AC coupled arrays experience that loss?
Well, I have some training materials that I could provide to them if you want to provide their information. AC coupled systems, you are converting DC to AC at the solar panel, and you're converting it right into 240, 120, 240, 60 hertz electricity that is then coupled into the combiner. Whereas with DC coupled systems, there's more DC to DC conversions. As I mentioned, like with the optimizer system, you're converting voltage from the solar panel through the multiple power point tracker initially. That's the first phase. And then to the optimizer. And then from the optimizer through the inverter system to the battery to match another voltage. So, the analogy or the kind of real world example I point people to is when you see transformers in the real world, what a transformer does is convert voltages, higher voltage to lower voltage or vice versa. Transformers have these big, massive heat sinks on the side of them because they're not 100% efficient. They lose energy when they're doing that conversion, and those heat sinks are there to get rid of that heat, so it doesn't overheat. This is something that is honestly hard to quantify because, as I mentioned, these DC to DC conversion losses aren't on data sheets because manufacturers aren't required to put them there. Manufacturers are required, inverter companies, I should say, are required to put efficiency ratings from DC to AC conversion ratings. So that's the data that you see on the sheet. These other losses are not the data is not readily available, and it's not going to be provided. Manufacturers of DC coupled systems aren't going to kind of willingly provide this information if they don't have to. So that's the best answer I can come up with. We like to just remind people of the other advantages of AC coupled systems, and that the power and energy of the systems are truly additive. By that, I mean, when you increase the number of batteries, you increase the energy capacity. You'll also increase the power capacity or power output of the system. With string inverter-based systems or hybrid inverter systems where the inverter is built into the battery, the power output is limited by the rating of that inverter. So you're going to hit a limit at some point where you could add even, some manufacturers have add-on batteries. You can add on more and more kilowatt hours, but you're going to be capped out in terms of power at the rating of that single inverter that's in that one kind of the base battery unit, if you will. So with Enphase, you're going to get more energy and more power when you increase the size of the system.
Got you. Well, thank you for walking us through that. And Tony, thanks so much for sharing your insights and really giving us a closer look at the exciting advancements from Enphase today, especially with your 4th generation system. And to our audience, thanks so much for your questions and joining in on the conversation. It really helped us to dive deeper into the conversation today. So thanks so much for tuning in. If you want to learn more about the 4th generation Enphase Energy System or the IQ8 microinverters or the other components from Enphase, be sure and visit us at signaturesolar.com. And as always, don't forget to subscribe and follow us on Facebook. And we'll see you next Tuesday at 3 p.m. Central, right here on Amp Up Solar Talk. We'll see you next time.
Bye.
Bye.